So, welcome to SuChAQuality first online training. So, what does SuChAQuality denote? It is basically sugar, chocolate, authenticity, and quality. And our journey on this project started on early April in 2020, and then we had the chance. Our proposal was granted in September, and then our grant agreement was signed in November, and our project started officially in January 1st, 2021, which is a 4-year project. We had already we already had our kickoff meeting in January 19th, where all our main participants attended, and we got uh, basically trade on some administrative issues of the project. And now we have to start the project with some activities. We are already starting our staff exchange. We already started one to Pakistan, and the second one will be to Germany, and our Serbian partners will also be visiting South Africa soon. Those who are already in our consortium know what Marie Curie RISE project is, but I just want to go over this again for those who were not able to attend our kickoff meeting and who are external stakeholders now in our training session. Well, Marie Skłodowska-Curie Actions Research, Innovation and Staff Exchange Program is a program that is based on secondments. What does a secondment mean? Secondment means staff exchange. So we set up a consortium, and in our SuChAQuality, we have 12 partners, 5 industry, 7 academic partners, and we will be exchanging within these partners to complete the tasks, deliverables, and milestones which have been mentioned in our grant proposal and finally finalized in our grant agreement. And in SuChAQuality, we have partners from different parts of the world. Here, I just wanted to highlight them in our map, in a world map. As you see, from different continents, we have different partners. And that is, in fact, one of the reasons why we started our activity a little late, because to catch up with the time schedule proper for our Chilean partners, we prefer to start a little late. We are so sorry for our Pakistani partners because it will end up a little late for them. But for the European partners, I think it is the best time combination. Okay, so let me introduce our partners. So Middle East Technical University is the coordinator. We are food engineering department here, and this is my first EU project, and luckily I have the chance to coordinate it. And then we have 3 more Turkish partners which will have significant contribution to our project, since they are industrial partners of our project, and they are basically the partners who has problems which we will be trying to solve. So Kayseri Sugar is one of the leading beet sugar manufacturers of Turkey. Tören Foods is a company where they are producing very high quality chocolate and wafer products. Durukan Confectionery is a very leading confectionery hard soft candy producer. And as you see throughout today's training session, we will be trying to address the needs of all these different sectors. I mean, chocolate, sugar, and candy sectors, to solve their quality related problems. Well, then we have also some academic partners, and as we have almost 7 academic partners, and our Polish partner from University of Warmia, Mazur in Olsztyn, Professor Danuta Kruk, is our leading scientist, and I am Noel Nurse from our post-action, and Professor Crook is the one who introduced me with this RISE project, so I would like to thank her again. And then we have Resonance Systems, which is an benchtop NMR producer in Germany, and they're also a very important partner for us because one of the most important techniques that we will be using in SuChAQuality is time domain NMR. We have a dedicated work package for that. And throughout the second month that we will be performing to resonance systems, we will be using time domain NMR techniques for performing quality analysis on chocolate and confectionery and sugar products. And our sixth partner, the Nottingham Trent University from UK. So I have known Dr. Morris since 2 years. We had the chance to work on 2 grant proposals. And luckily the third one, this one was funded. And Rob Morris is a physicist, Dr. Morris, and they are going, NTU, Nottingham Trent University, will help us in this project to develop mobile NMR sensors which can be used in the plants for quality control purposes. In other words, we might be coming up designing a device which will measure some parameters, for instance, for a Turkish delight. So that is our goal in the project in the long run. And we also have SGI Isotech from Republic of Serbia. So Ivan Smajlovic is the leading PI, and they are an expert on IRMS. So for authenticity analysis, we are going to get support from our Serbian partners. And then we have our Chilean partner from University of Concepcion. They are the chemometric specialists for our project. We will be acquiring significant amount of data. And for near-infrared spectroscopy, using chemometric approach is usually the way that is followed. But for time domain NMR, it is not as common as NIR. So in this project, we will have data acquired from different techniques. So we will try to apply this chemometrics. Chemometrics means statistical techniques to the data that we acquire. And that is why we will be performing secondments to Chile. And then our NUST, our Pakistan partner, National University of Science and Technology. There's a very specialized biotechnology institute in Pakistan. And in SuChAQuality, our Pakistan partners will help us to produce functional confectionery products. And I will also talk about that, what I mean by functional. But functional means like a product which has some extra features. And they are using, they are expert on algae, and the sugars that are obtained from algae will be added to our formulations, the soft candy formulations, and we will be developing new candy formulations, maybe having lower calorie, and the quality attributes of these candies will be investigated afterwards. And then we have our Belarus partners, so Institute of Physics of National Academy of Sciences, and Mikhail is already here with the ESR of his institution. So they are also a very good expert on near-infrared spectroscopy, and he will be giving a lecture on Friday about the basics of near-infrared spectroscopy. And we will be performing secondments to Belarus to learn more about NIR. And our second NIR partner is from Stellenbosch University from South Africa. And Professor Morena Manley is the leading PI. And there's also a very nice advanced infrared spectroscopy lab over there. So we will also be doing some near-infrared analysis at South Africa too. So as you see, the consortium, the partners have been structured in such a way that all of them are complementary. and we have definite roles for each partners, and the goal is to get to transfer knowledge between these partners so that we will increase our knowledge on different techniques. So we will learn more NIR from our Belarus and South African partners, and maybe we will teach them how we can use time domain NMR for different purposes. Or we are going to learn chemometrics, a very important data analysis tool from our Chilean partners, which we will be easily integrating to our own research. So RISE actions, RISE projects should not be only told as a project where we have certain goals and we want to accomplish this. Our overall goal is we have a consortium that includes many researchers, many technical staff. At the end of 4 years, we would like to increase the knowledge of our consortium of these partners, and also we want to have an impact on, for instance, in the case of SuChAQuality, on the confectionery sector. We would like to introduce the knowledge that we have obtained to the confectionery, sugar, and chocolate sector. So this is more like some administrative info about our project, the partners, RISE program, and so on. Now I would like to start with what is the rationale of our project. Well, how this project idea came into our minds? Since 3 years, we have been working with confectionery products. In our lab, we produce different functional sugars, gelatin-based, starch-based, pectin-based, and we are also working crystallization of different confectionery products. And based on that, we realize sugar is really a very unique multifunctional ingredient for food industry, which cannot be replaced. And when you look at the sugar production in Europe, you see that in Europe, we have almost the world's leading producer of beet sugar consumed worldwide, making the world's largest producer of beet sugar. However, the important point is that in global production, sugar is obtained from 2 sources, beet sugar or the cane sugar. For instance, in Pakistan, we have a lot of cane sugar. And if you look at in terms of the production in the world, you see that 80% of world's sugar production comes from cane sugar. But in Europe, there's the beet sugar. And why in Europe there is the beet sugar production? Because the climate is not proper for cane sugar production. And that is why, since there is also the possibility that we can import cane sugar, the trading regime for sugar is somehow different. And sugar is the only agricultural sector in the European Union where production was subjected to a quota system. And in 2017, this quota system ended. And what happened is, after this quota system ended, there is also now cane sugar refineries that started to take place in Europe. But still, like Poland, Ukraine, in Germany, beet sugar production is very important for the agriculture. And these countries try to protect their agriculture by implementing regulations on sugar industry. And also this is the case in Turkey. So in Turkey, we don't produce cane sugar. In fact, it is not proper. Cane sugar importing is also not allowed. So there are very small quotas. So a very strategic product, it is authenticity or it is quality is very important. Well, why I'm talking about this? Because sugar and basically sucrose is going to be our first product that we will be addressing in SuChAQuality. And we have a partner, beet sugar producer, who will be dealing with this sugar work package, and we will be trying to solve sugar quality and authenticity problems. Well, in addition, through the sugar value chain, we have other important actors. Confectionery is the second important category in the sugar value chain. And what is a confectionery? Confectionery usually is a food with a relatively high sugar content. In other words, the sugar industry, sucrose industry, is providing input for the confectionery industry. And confectionery industry also has a very important share in the food market. It accounted for 11% of the food revenue and 5% of the volume sales in 2018 in the world. And in terms of the total revenue in the market, Europe is the second market share, followed by South America, with a total market share of 11% in 2019. Chocolate products, sugar confectionery, pastries are the main segment of the confectionery industry. And there is this association in Europe, CAOBISCO, Chocolate Biscuit Confectionery of Europe, stating that almost 9% of the European food innovation is coming from the confectionery sector. And in this project, in SuChAQuality, our focus will be soft candies, hard candies, the sugar confectionery, in other words, and also chocolate, which had almost 60% of the total confectionery revenue in 2019. So SuChAQuality will focus on the quality and authenticity problems of these two sectors, which are closely feeding each other. And beet sugar and confectionery industries will be the main stakeholders of our project. So I tried to give the rationale, the products that we are going to work on SuChAQuality. And now let us look at in more depth what will be the problems that we will be referring. Well, I told you that in the world, 80% of sugar production is coming from cane, 20% is almost wheat. And beet producing countries have regulations to protect the beet growers in their country in terms of agriculture. And they do not want the cane producers to interfere to the market in a significant extent. And when I was talking with our beet sugar producer, Kayseri Şeker, it came up with the idea that, well, is there a technique that we can differentiate beet and cane sugar? Well, the answer is it's not easy. Why? Because we are talking about sucrose. Sucrose is a disaccharide. So it is a disaccharide consisting of glucose and fructose. And sucrose is a disaccharide which has a perfect crystallization ability. It is one of the ingredients which can be obtained in pure form. So we have beet sugar, cane sugar, they almost have the same chemical structure. And how come we can identify or we can differentiate these two sugars? Well, sugar beet is known as a carbon-3 plant, which means it follows the carbon-Benson mechanism in photosynthesis. Sugarcane is carbon-4 plant, Hatch-Slack mechanism is observed. The different carbon dioxide extraction mechanism of sugar beet and cane show that ratio to stable isotopes, carbon-3, carbon-4, can be used to distinguish them. And based on this, currently, isotope ratio mass spectrometry has been used as the main technique to differentiate the origin of the sugars. And as another technique, high resolution NMR or carbon NMR spectroscopy are being utilized. Well, what are we going to do in SuChAQuality is we will be collecting sugar samples from different parts of the world, and we will first make a classification analysis based on IRMS with the help of our Serbian partners, SGI, because IRMS is currently the method that can best differentiate beet and cane sugar. So we will be collecting different beet and cane sugars. So we will identify the differences based on this known technique, but also we will be trying to use other techniques that we are going to see later and we are going to see throughout the project to identify if there is any potential to identify these sugars. Well, if you talk about a molecule that has almost the same structure, then where will the difference come from? Well, the thing is, beet sugar and cane sugar are crystallized in different ways during the production. So, detecting small differences in the crystallinity of these sugars could reveal some information on the differences, but we have to relate this with the known technique which we already have. So that is why we are going to, one of the goals that we will have in SuChAQuality will be to identify the differences in these sugars. Well, this is a flow chart from Kayseri Şeker. It shows us a very nice flow chart of the sugar production, sucrose production in all details. Well, this is, identifying cane versus beet sugar is not the only issue that sugar manufacturers are facing. Another important thing is, well, especially during the purification, evaporation, this crystallization phase, we have another issue that could affect the sucrose crystallization. So what is this? The presence of polysaccharides in sugar beet and cane juices cause diverse negative effects during sugar manufacture. Polysaccharides usually come from the plant cell or from microbial activity. And among these polysaccharides, dextrans, glucose monomers, deserve special attention. So what happens is, if you have dextrans present in the beet juice which you're going to evaporate, the viscosity could have increased, there could be blockage in the process line, and the most important thing is it could decrease the output of crystallization. The crystal shape distortion could be observed, which sugar manufacturers do not want to see. So the R&D manager of Kayseri Şeker, when we had the discussion, said that, okay, well, we know that there are certain methods which could detect these dextrans, but we want an online, it's going to be better to have an online quick procedure for detecting the presence of these dextrans in the juices so that we can quickly take some control. Well, in that regard, developing alternative methods that can be easily implemented on process line is still on demand by the sugar manufacturers. There are already some methods, as I said, but still some online methods are in need. So SuChAQuality will be addressing this problem of beet sugar manufacturing as well. maybe by examining the beet juices with a mobile NMR sensor, we will be able to predict the presence of dextrans in a quicker way, and that is going to be a nice solution that can be proposed to the sugar manufacturers. Well, this is the first aspect. The second associated industry of SuChAQuality, as I mentioned, is the confectionery and chocolate. And for that purpose, we have two partners, Durukan Gıda and Tören Food. So these are leading manufacturers in their industries, and these companies will introduce us their problems. They will teach us the processing of the confectionery and how we can help them to solve the quality related problems. But the thing is, first of all, you may think, okay, we are now on a trend where people are always trying to eat healthier foods. And confectionery sector is also facing with this challenge because confectionery products are high in sugar, high in calories. So in SuChAQuality, we thought that we should also address this aspect of the confectionery products by creating some new confectionery formulations, by adding some functionalities to our products. And with that concept, with this healthy food demand of the consumers, we thought that we may create, for instance, formulations that will have lower calories by integrating algal sugars. And today, after my lecture, Professor Hussnain will give a lecture on the production, or what basically we know about algal sugars. So SuChAQuality will be addressing this special case through the development of a functional product with the help of our Pakistan partners. And of course, Durukan Confectionery will be actively involved there. To ensure quality in confectionery sector, different methods have been used. Well, what confectionery products usually have importance is the moisture content. We have a high sugar product and we want to measure the moisture content. But whenever you have high sugar content, the high temperature drying methods for measuring moisture content does not work due to caramelization reactions. For those who do not have any idea about what caramelization is sugar degradation reaction. So if you want to measure the moisture content of a product that contains high sugar, you cannot just heat it to high temperatures and then look at the weight loss, because during that you will observe some sugar degradation, which will also cause water release, and that will change the moisture content results significantly. That is why vacuum drying or Carl Fischer titration, which is the iodometric method, is usually used in confectionery industry. And these methods can take time. Vacuum drying, let's say 4 hours, 6 hours. Carl Fischer titration requires also for equilibration to come, and it generates a lot of waste. So in terms of sustainability, it is not the desired way. Well, in addition, we know that there are studies where NMR, infrared, and microwave spectroscopy has been used for that purpose. And even in some NIR instruments, I know that there are modules for measuring the moisture content. Well, still, these methods are not very commonly used by the confectionery manufacturers. So there is still more opportunity for simple online processes with the methods analytical techniques that we are planning to use in the project, we will try to show the companies, the confectionery sector, that okay, there are really alternative ways for them to do these analysis, maybe with an instrument which is capable of also doing many other experiments, because that is usually a very important point for a producer. If you are going to buy an instrument for one quality measurement, and if you know that you can use this for many other purposes, that's going to be great. And a time domain NMR instrument, for instance, can measure moisture content, can measure oil content, and can even measure crystallinity. Or with that NIR instrument, we will say that, okay, you can measure this, so you can easily have an idea about the quality of your product. Well, in confectionery sector, we have crystallization, a very important problem, and that can be measured through the glass transition temperature or by performing X-ray diffraction experiment, but an XRD instrument is not available in most of the confectionery producers. So how can we quantify the crystallinity or crystallization? Well, all these problems will be addressed by introducing new quality tools. Okay, algal sugars will be used to create new functional products, and XRD experiments as a complementary technique will also be performed at our Pakistan partner. So we will be addressing not only a functional confectionery product development, but also use of a common method which will complement the experiments that we are doing by other techniques. Okay, so that was about basically the rationale. So until now, I might have gone fast, so let me slow down a little. So what I have talked is what is SuChAQuality about, what is the rationale behind, and what are the problems of the confectionery sector, and how we can address their problems. Well, when you hear the word confectionery, the first product that comes into your mind, of course, is going to be the candies. So you see here the colorful candies. And candies will be one of our main products to work on. So what is a candy? How are candies made? Well, all sugar candies, whether brittle, creamy, or chewy, usually include two essential ingredients. If it is a hard candy, we have sugar, water, and colorants. If it is soft candy, as I will be talking later, we also have some gelling agents. So in overall, we have very different confectionery products, but in overall, we have sugar, water, or different types of sugar present in all the formulations. For instance, here you see a lollipop. This is what Durukan Gıda calls. So this is like a ball-shaped candy, stick candy. And if you look at the ingredients, you might have a filling for that candy. Sucrose is used. We use flavorings. We use colorants, and citric acid as an acidity regulator is added, and glucose syrup is also an additional sugar source that is added to these hard candies. Well, glucose syrup or corn syrup is kind of preferred in hard candy products, but as we will see later on, for instance, for Turkish Delight, we don't want to add corn syrup in the formulation. And this is going to be something that we will discuss, but usually the original recipe of Turkish Delight includes usually sucrose as the main sweetening agent. But in order to make the process easier, in order to decrease the cost, manufacturers could prefer to use corn syrup, and that might cause some other problems, as we will be discussing in a couple of minutes. So here you see a lollipop candy and the ingredients, and in fact, it is not very difficult to produce. Well, cooking is held in a temperature and pressure controlled vacuum cookers at between 140 145 Celsius. So usually we have the mix, we evaporate it, then we mold it, and a very simple process that is followed in a lollipop confectionery. Well, another candy, as I said, Turkish delight. Turkish delight is another category. So in Turkish, we call it lokum, and it is not only composed of sugar and water, but Turkish delight also includes starch, which gives it its main jelly texture. We could have some nuts like pistachio, almond, hazelnut inside, but the main chewy texture of Turkish delight or lokum comes from starch. If you look at the lokum production, you see we have some boiling step, but normally we do not have corn syrup as a sugar that is added to Turkish delight. So sugar normally is sucrose, and that is how it has been defined in Turkish Food Codex. But the thing is, as I said, corn glucose syrup might be added to that. Well, for lokum manufacturers, this might be a problem, but for normal soft candies, this is usually the way that is produced because it gives better texture. And even I will show you that we have used corn syrup or glucose syrup in the gel candies that we have made in our lab. Okay, so we have some physicists among us. Maybe for those they do not know what actually a gel is or what are the requirements of having a gel. Well, let me put some gel slides in between, so it will be like a very short, tiny food chemistry lecture. My students will recognize probably my slides. Well, gels normally are systems which are intermediate between solutions and dispersions. And in a gel system, we have a macromolecule which partially aggregates to form crosslinks. And over there, you see we have like a network structure. And within this network structure, we have water that is trapped among the polymer chains. And this is what a gel is. And Turkish delight is in fact also a gel. We have starch that is creating this network and trapping the water inside, creating that soft, chewy texture. So we have basically hydrocolloids in soft candies, which are acting as gelling agents. And hydrocolloids, or the macromolecules, are high molecular weight hydrophilic polymers which contain polar or charged functional group, rendering them soluble in water so we can create gels from them. And in the confectionery sector, we use different type of gelling agents. One of the most popular one, you know, the gummy bears probably. These gummy bears, for instance, mostly made from gelatin, or the Haribo, for instance, confectionaries are mostly made from the gelatin. Or there is starch as the gelling agent, and another one is pectin as the gelling agent. And pectin, I will also talk about pectin in detail. It is a gelling agent which is extracted from the plants. It is one of the materials that is found in the plant cell wall, and it has good gelation ability. In fact, Pectin is responsible for giving a texture to a jam or marmalade. So it is the macromolecule, it is the polymer which makes jams and marmalades. Anyway, these three polymers are usually used a lot in confectionery industry to create soft candies. We mix these polymers with sugar and with sucrose plus glucose syrup to formulate different soft candies having different textures. Well, for instance, for vegan people, normally rather than gelatin, the other, like let's say starch or pectin is used as the gelling agent. And whenever you use starch as the gelling agent, if you modify the properties, you can also obtain a very stretchy texture, for instance, and some consumers prefer such candies as well. So by using these polymers, you can obtain candies with different textures. And if you look at the physical mechanism of these candies, or how this water entrapment is occurring in a mechanistic level in these candies, we see that the responsible things are the crosslinks. Crosslinks means the polymers are coming closer to each other to trap water, and we have different types of crosslinks. I'm not going to go into the details, but I just want to show you that such different cross-linking mechanisms exist even in candies. Maybe you have just used gels for some other purposes, and you have never thought that, for instance, hydrophobic interactions are also taking place in a Turkish slide or in a candy, but in fact, it is the case. We talk about such different intermolecular attractions that can contribute to a cross-link formation in candies. Okay, what type of, let's look at, for instance, different types of candies very short. Gelatin, for instance, there are different gelatin sources. In Turkey, we usually use bovine gelatin. And over there, you see a gelatin-based soft candy. This is very similar to what you usually see in most of the gummy bears. And it is not very difficult to obtain a gelatin-based candy. So you have the gelatin solution, you mix it with the sugar solution, and you mix it, let's say, at 85 Celsius, and then you put it in molds. Gelatin is a perfect polymer which can easily gel upon cooling. So you don't need to apply an additional gelation process or a process which will induce gelation, because following the heating, the denatured gelatin will aggregate to form fine stranded transparent gels. And that is why gelatin is usually preferred by the confectionery industry to make candies. And starch is another one. It's not very easy to make candies out of starch. One of our ESRs has worked in starch candies before. So Esma is here, she knows much better than to make candies, but you need to be careful about some tricks. But once you arrange the temperature and whatever the other stuff, you can easily come up with an appropriate formulation. Here you see, for instance, some candies, starch candies that are not yellow but getting brown. Well, why they are getting brown? Because we use another sugar in these candies. This other sugar has more ability to participate in browning reactions. Browning reactions means the reaction which are responsible for making a food brown, like in coffee, for instance, we have browning reaction, which gives coffee its original taste. Anyway, I'm not going to go into that detailed chemistry, but with starch, usually you cannot make pure transparent gels like gelatin, but you will have more opaque gels. But with the proper conditions, you can obtain this chewy structure. And Turkish Delight is a candy that is made from starch, and it also requires some unique conditions. Well, we have also some, I think, participants here from Duruka, so they may know the processing much better than I do. So at the end of in the discussion part, they can also add some information maybe that I missed. Okay, pectin is another polymer that is usually that can be used to make candies. And again, this is going to be totally plant-based because you're not going to be using gelatin. But the important thing in pectin-based candies is you need to put really high amount of sugar, and you also need to create an acidic condition in the gel. Because once you do not satisfy these requirements, you cannot make a gel from pectin. Because pectin, due to its molecular structure, let me show you that. Pectin is a polymer which consists of galacturonic acid. And for pectin to form a gel, these carboxylic acid groups that you see in the structure has to be protonated, so we will have hydrogen bonding, and this hydrogen bonding will contribute to cross-linking. So with this cross-linking, we can only create pectin gels, and depending on the type of the pectin that we have two varieties, but in pectin candies, we can prefer high methoxy pectins. Well, acidity and high amount of sugar are important requirements to make a candy. Okay, so let's, before getting too much lost, make a wrap what we have talked so far. I started with a discussion about sugar and beet sugar, cane sugar, why beet sugar authenticity is important, and how is sugar production in the world, and why we need different tools, quality tools for characterizing beet or cane sugar. And later on, we said that, okay, in SuChAQuality, we are not only talking about sugar, but we are also talking about another sector, which is confectionery sector. And the confectionery sector, specifically we focused on candies, hard candies and soft candies. In the hard candies, I introduced you the lollipop cakes. And in the soft candies, I talked about lokum, Turkish delight, but I also mentioned about other soft candies which can be made from other polymers. By the way, there could be also other hydrocolloids, other polymers, which can be used to make also candies. But these three ones are the ones which we usually use commonly. Okay, now I will just talk about corn syrup, and then we'll give a short break because I know that for 2 hours none of us can concentrate, so it will be a very short break. But let me first talk about corn syrup. Well, again, if you are not a food scientist, have not been involved in foods very much, but you probably might have heard that corn syrup is another additive that is commonly added to the foods. And in fact, there are also, the thing is that corn syrup might be added really in high amounts to the foods, and some research have shown that the increasing obesity could have been related with increased level of corn syrup containing products. But still, investigation is underway. I'm not going to go to the nutrition perspective. I just want to give you the idea what corn syrup is. Corn syrup is basically a sugar syrup that is obtained by hydrolyzing starch, and that is usually added to formulate is also sweetness. So here you see, for instance, starch. Starch is hydrolyzed to obtain maltose and glucose, and later it can be isomerized also to fructose to increase its sweetness. So corn syrup is a syrup that is made by hydrolysis of the starch. But the thing is, since it can be produced in high amounts, manufacturers really put a lot of corn syrup to the product, so the caloric values increase, and then we see this increased levels of sugar consumption. There are different levels of corn syrup that are produced in the market, and depending on what type of confectionery product you're using, you can select a different corn syrup. And here, for instance, you see at the end there are HFS 42, HFS 55, HFS 90. What does that mean? That means corn syrup is basically the produced corn syrup have different degrees of hydrolysis, and this different degrees of hydrolysis can not only affect the sweetness but also the physical properties. And related with corn syrup, I would like to mention one point. As I said, Turkish delight normally should have sucrose in it as the sugar source, but manufacturers can add corn syrup, and once corn syrup is added, the formulation, the quality might improve, but the thing is, then the real Turkish delight manufacturers could face from an unfair competition in the market, because the ones who are using corn syrup can be producing it at a lower price. So using corn syrup can be considered as an authenticity problem in sugar industry. And when I talked with beet sugar manufacturers, they were always addressing me the question if there is a way to identify the source of the sugar in a product and an easy analytical technique. The answer is not very easy, but based on the physical properties, we could make some predictions. And throughout SuChAQuality, we will try to follow these physical properties in accordance with the formulations and see whether we can understand the presence of corn syrup. Okay, let us give a 5-minute break, and then I will be back to talk about gelatin. So I'm almost half of my slides, so I think we will have enough time to finish the rest of the slides. Okay, let's give a 5-minute break, and then I will be back at 4 or 5, yes, 5 minutes after. It will not be correct to look at the hour, because all of us in a different time regime. Okay, see you in 5 minutes. I told that in the candies, gelatin is an important polymer which can gel easily. Well, here in the slide, you see some information about gelatin, and gelatin is obtained by using collagen, which is the main connective tissue protein. And bovine, porcine, and fish are usually the sources to obtain gelatin. And if you look at the process, so collagen, once denatured under alkaline or acidic conditions, we can obtain gelatin. And gelatin, if further hydrolyzed, we obtain collagen hydrolysate. So here you see a comparison slide for collagen, gelatin, and collagen hydrolysate in terms of molecular weight. But for confectionery products, we are usually preferring to use the gelatin. Well, a problem in confectionery industry, especially like in countries in Turkey, Bovine gelatin might not always meet the demand, and porcine gelatin is more available. And if you look at how porcine and bovine gelatin are different from each other, you see that the amino acid compositions of these two gelatins are different. But we also do not have an easy analytical tool that can identify whether a candy is made from porcine or bovine. Well, there are some molecular techniques like PCR or some chromatographic technique, and even there are some studies which have used FTIR, but the method still needs further improvement. So we will be also doing some analysis through our project to be able to differentiate porcine from bovine gelatin, at least to answer the problem of disidentification in several confectionery products. So, and if you look at the partners, for instance, in Turkey, porcine gelatin you cannot buy anywhere, and I think that this is also the case in Pakistan. So you cannot find porcine gelatin. Only for research purposes you can use it. So if we can also identify this, if we can find a way, let's say by using TDNMR, that will also be helpful. Okay, we said that we keep on discussing the quality problems, confectionery, candies, and so on. And Drukan Confectionery provided me some very valuable slides on some of the quality problems that they have been experiencing. Well, let me show you these quality problems. And there are two categories. First one is on lollipop and another hard candy, bonbon style candies. And the other one in soft candies, drudgy like candies. Well, three problems they said that could be an issue: inversion, stickiness, and breakage problem. Well, these could be the problems that we can see in confectionery. So let us now see what do we mean by inversion. Well, sugar inversion means sucrose being hydrolyzed to glucose and fructose. And this is usually a process that takes place in the presence of acid. And in the case of a candy, this can happen throughout the shelf life, and that could lead to consumer complaints. So in the figure here, you see a light pink color sugar candy, which is basically the exposed to inversion. And on the other hand, on the right, you see a good quality candy. And on the right, you see two candies that have stick to each other, which could be a problem in the production line. Well, inversion problem, the question here is, can we predict whether inversion will take place in a candy beforehand by using an easy method? So this is something that we will be addressing. Stickiness. Stickiness is something that is related with moisture uptake. It is also related with the amorphicity of a candy. The more amorphous a hard candy is, the more sticky it is going to be. So if you can develop a method that can give you idea about the amorphicity, then you can predict whether the candy that you produce will stick in the package or not. Well, there are also some drudgy-like candies which also experience some quality problems. Here you see the products of Drukan Confectionery, and these are the raw materials are usually acids, sugar, and flavor and colorants. And there is also to have for the inside filling some hydrocolloids. For instance, here it could be gamma arabic, modified starch, or maltodextrin. So they can be also used as the filling of these drudges. And what I mean by the drudges is this type of figure, this type of products. Well, you see here both good quality and not desirable quality candies or drudges. Well, what are the problem? If you look in closer, you see we have leakage of the interior filling coming out, or we have more white spots on the outer surface. Well, how can we predict, or what type of solution we can come up here? Well, of course, these quality problems are totally related with how these candies are produced. However, the thing is, if you look at the intermediate stage of these products, and if you can do some quality analysis at the intermediate stage, you can easily have an idea about whether this drudge will experience that leakage problem or not. So this is kind of an approach that we will also be testing. So some of you maybe will be working on drudge samples on NMR, on any other technique to figure out this problem. Well, in such a quality, quick, reliable, affordable, efficient quality control methods will be developed to replace the traditional current methods that have been used in the sugar confectionery industry. Another example that I can give, one of my students will be starting her secondment in Germany very soon. And what we are going to do there is we prepared some hard candies made by using different corn syrups and using sucrose. And we will do some time domain NMR measurements in Germany to have a profiling of these hard candies and to see the crystallinity, the amorphicity, how these behaviors are changing with respect to formulation. And Durukan and Törengıda will also send us some samples, and we will also be evaluating these samples for quality problems. Okay, so that was all about the confectionery and sugar section of our project. So you should now have at least some idea in your mind about what problems the confectionery sector could suffer from and how we can address these quality problems in our project. Another important partner of us in the project is a chocolate manufacturer, which is Tören Food Company that is located in Gaziantep, which is a city in the southern east part of Turkey. It is a very nice city, and it also has very nice foods. For those of you who will be visiting Tören food, so you will have the chance to eat very delicious Turkish cuisine over there. So in parentheses. Anyway, chocolate is a food product that also suffers from significant quality problems. Here you see some nice chocolates which has the desired quality characteristics. But not all chocolate will have these nice quality characteristics. And we will be discussing what these quality characteristics are. Let me first describe the story of chocolates from the cocoa beans. So chocolate starts from the cocoa beans. First, the cocoa beans are harvested, and then the harvested cocoa beans are fermented. Following the fermentation, the beans are dried. And later, we have the roasting stage to introduce more flavor to the cocoa beans. And following the roasting, we have cracking and winnowing processes, which removes the shells of the beans. And then we add the sugar or sweetness and flavor. We grind the cocoa beans. And finally, we temper and we mold. Well, there are some important steps in this slide which I would like to mention. First of all, roasting is an important step because in the case of roasting, we let some browning reactions to take place which will decrease the acidity of the cocoa beans and improve the taste of the beans. So this bitter taste of the bitter chocolate will mostly be imparted during this roasting stage. And there is also this winnowing stage, which has the shells being removed. Well, you see that grinding of chocolate with sugar requires some special equipments, and in the slide you see we have cylinder-like shape equipments. It is important that you need to perform this grinding step sufficiently such that sugar crystals will not come into your mouth when you have the first bite to your chocolate. Because if you do not sufficiently grind it, you will feel the sugar crystals, and which is not very nice because that will be blocking the nice flavor, that melting behavior of chocolate in your mouth. But more important than that is the fourth step that you see here, which is tempering. And I will talk about tempering in a minute, but let me first show you the composition of the cocoa beans. So you see in cocoa beans, we have some small amount of water. We have cocoa butter, which is almost 50%. We have proteins and amino acids. We have sugars. We have fiber. We have phenolic compounds, minerals, and also some amount of caffeine. Well, phenolic compounds. Bitter chocolate usually is considered to be healthy, especially if it doesn't have a lot of sugar. Why? Because phenolic compounds are known to be antioxidants mostly, and antioxidants are known to have health effects. So that is why bitter chocolate is known to be more healthier. And the difference between bitter chocolate and milk chocolate is that in milk chocolate, in addition, we have milk powder attached. And in the case of white chocolate, we just have cocoa butter that is used. So we have just cocoa butter that is being used as the main chocolate material in white chocolate. Okay, why I'm showing you this composition? Because this composition is showing us that in the physical properties of chocolate, the most dominant contributor is the cocoa butter. And cocoa butter is a fat which contains many different triglycerides. We have palmitic acid, stearic acid, and oleic acid as the fatty acids. And cocoa butter is mostly giving the desired texture the chocolate. Okay, I will be showing one short video here. This is a conching or a grinding instrument. So you see the cylinders over there, which this is a laboratory type. And if you have a secondment in Torangada, you will see much better the real industrial level equipments. But this benched up equipment helps to have a smooth chocolate that is free from crystals. The sound is what is responsible, what means a good quality. That is what we usually would like to see. We call it the snapping, the best snap chocolate, and that desirable chocolate sound will only be possible in a good tempered chocolate. Tempering means controlling the temperature while you're cooling the chocolate. So controlled temperature means tempering. And if we do not do the tempering correctly, what is going to happen is you will not have this best snap, but also you might have some undesirable whitish appearance in your chocolate, as you see in the slide. So you see we have whitish fat crystals that migrate to the surface of chocolate, which is not something that we would like to see. So tempering process in chocolate is a very important process which determines the final quality of chocolate. And it includes three basic steps. We have a heating stage. We first heat the chocolate to get rid of the crystal history. So we melt all fat crystals, and then we cool it to form a new set of starter crystals. And we carefully heat again to melt the unstable crystals so that only desirable crystals will remain. In chocolate, we could observe six different crystal structures. But among these, we would like to have the type 5 crystals in higher amount because that is going to give us the best texture. So as you see, the form 5 one gives us a shiny, firm, great snap, and it melts easily in your mouth. So that is usually what is being looked for in a good tempered chocolate, and we would like to have form 5, type 5 crystals in a chocolate. And if you want to look at the tempering in more detail, you can look at the slide, and in the bottom of the slide, we have a tempering curve, which shows us the heating, cooling, and reheating stage. And on the table, right next to the plot, you see the crystals having different melting temperatures. So this heating cycle is required or is adjusted based on the melting temperatures of the crystals. And in the chocolate, we would like to have as many type 5 crystals as possible. Well, tempering could be achieved via different ways. You can do a benchtop tempering, and there are some instruments, benchtop instruments capable of doing the tempering. And you can even do the tempering by using seeding. Seeding means you can add you can add crystals which are, or chocolate particles which are already in type 5, so that while cooling, the other crystals would like to resemble to these type 5 crystals, and we will have the crystallization. We can have on the tempering on a marble, or we can have, there are continuous tempering systems that are implemented industrially. And whenever you visit our labs, you will have the chance to do, and maybe we will be teaching you to do tempering. And also, as I told you, when you do your second month's tutoran food, you will have the chance to see the real tempering over there. Well, why I am giving tempering that much importance? Because as I said, tempering is what gives the chocolate it is final properties. And in the case of tempering, there is some quality indices which are usually used, like tempering index is one of these quality indicators where we look at time temperature uh, plot or for the chocolate, and in that case we can obtain a tempering index. But this tempering index value, I know from the literature that there are some other methods to give a good prediction to tempering index is usually looked for. And in our project we will also try to see whether we can develop an NMR based method for understanding the tempering index. Well, what happens if you do not, if you disrupt the tempering of the chocolate? For instance, you have the chocolate, you did not store it in a proper condition, and you let the chocolate to melt. When it is solidified, again, you will see that the tempering will be disrupted, and we will have the fat bloom, which is the fat crystals that are observed on the chocolate. So this is an important problem and that affect the chocolate quality. So, but this is something that is seen afterwards. What we want to do is in an online processing environment, developing a method which will predict the tempering index quickly will be a very good output of our project. Okay, do you know this product? Let's see who knows this product. Selan, maybe you have seen in the US in the markets already. Or if you have not seen, I recommend you to try it. Okay? So any of you in South America, do you have this product or similar products? This is known as peanut butter cups. Maybe different varieties of this exist. Peanut butter cups. Okay? Well, why I'm showing this? Because if you have a fat filling inside a chocolate, this fat filling could also cause another blooming problem in chocolate. And what is this blooming problem? So here you see again the peanut butter cups, and here another uh, representation. If you have a high fat filling, this fat filling could dissolve the cocoa butter of the chocolate and then could recrystallize, disrupting the already temper of the chocolate and decreasing the quality of the final product during shelf life. So this is another quality problem that can be seen in chocolate industry for the products that contains high fat content filling. And for instance, if you have a peanut containing chocolate or walnut containing chocolate, peanut hazelnut butter containing chocolate, this migration fat bloom could be a problem. Well, another problem could be the sugar bloom. Silent killer. That is true. Oh, okay. Thank you, Margarita. Uh, well, that is exactly so something that is going to destroy the quality of the chocolate product. And sugar bloom the sugar crystals migrating to the surface, which is also something not desired. So chocolate quality problems then can be summarized as having an idea about temperature index, blooming, or for the food engineers among us, they will know better that rheological problems of the chocolate could also lead to some quality problems. Or whenever you want to work with cocoa butter substitute and emulsifiers, they will all lead to different quality problems. We will try to address as much as we can to these quality problems in chocolate. And another uh, product that Turan Food is very famous is the wafers. And in wafer-like products, softening due to migration of the filling to the wafer layer. So this is also something that can easily be predicted by using magnetic resonance imaging. If we will also try to see if we can have an idea about this migration in the vapor filling by using imaging. So many quality problems we describe in the confectionery sector. How will we address all these? Now let us summarize them. We will be using time domain NMR, resonance systems, and Middle East Technical University will basically be helping to resolve the problems by using time domain NMR. And we will be using another technique, for instance, for the sugar, for identifying the beet and cane sugar, for gelatin candies, or for other characterization or quality problems that we experience in the candies by fast field cycling NMR relaxometry. And this will be done at our Polish partner in Professor Danuta Krug's lab. And we will also be developing mobile NMR sensors by our UK partner, so to solve these quality problems. And near-infrared spectroscopy, and Dr. Mikhail also said that maybe terahertz spectroscopy could also be added, even this was not something that we thought initially, but we can also integrate that. And this will be done by our Belarus partners, and also NIR will take place again at Stellenbosch University and South Africa. And our Chilean partners, we will have a lot of data from these experiments. So, and they're doing also spectroscopy, infrared spectroscopy. So at some point we can also use the spectroscopy tools over there as well. So in SuChAQuality, scientists that have expertise on the methods of IRMS, time domain NMR, FFC NMR, portable NMR design, NIR spectroscopy, chemometrics, beet sugar, sugar confectionery, chocolate confectionery manufacturers have gathered to form a consortium to develop new authenticity and quality methods for sugar and confectionery industries. We have food scientists, physicists, chemists, engineers, statisticians, biotechnologists that will be taking place in our project. So we can easily say that we are talking about a multidisciplinary consortium. We have 7 different work packages, but 5 of them are actually the real work packages. So one of the work packages is use of TD-NMR. The other one is use of FFC-NMR. We have mobile magnetic resonance hardware development as the 4th work package, and NIR and IRMS use is our 5th work package, and the chemometrics is our 6th work package. So throughout all these work packages, we will be trying to solve the problems that we have described. Okay, SuChAQuality will not be involving only staff exchange, but we will also do as much as training as we can. This 3-day training that we have designed is just an introductory one, because we are not talking about the details, or we are not talking about the depth of these methods. Well, as you see here, we are planning to have 5 dedicated training schools on chemometrics, on NMR fundamentals, on hardware design, and IR spectroscopy, and on food authenticity. So we have the necessary budgets to do these training schools, and this is totally going to be done for young researchers, for ESRs, for PhD students, and sometimes master's students, and of course for experienced researchers who would like to have experience in these areas. So with this training schools, which will take normally 4 to 5 days long, we want to increase your knowledge on these techniques. We will have short workshops where we will be presenting our results on what we have found throughout the project, or some introductory workshops. And we will let the ESRs and ERs in our project to attend to conferences which they would like to attend. Here I have listed just some example conferences, like there is the World Confectionery Conference, I think, which we definitely should show up, or the recent Advances in Food Analysis Conference, which also as SuChAQuality consortium we should participate. And there will be also webinars. Maybe we will have more webinars throughout this 4 year. So regarding again on analysis and interpretation of near infrared data, data analysis by relaxometry, or use of microalgae extracts in foods, and XRD and crystallization. Just examples. We could have many more training schools and workshop and webinars. Well, as you have seen, candy and chocolate maybe is more than we know. There is really science behind candy and chocolate. And in European Union projects, the goal is also to disseminate and to exploit the results, and also to introduce science to other communities. Like European Researchers Night is going to be one of the activities that we will be participating. And also, as Matthew, and we will be setting up an ESR group with all other ESRs, early stage researchers in the consortium, to perform some activities. Like in Turkey, for instance, we plan to go to schools to introduce the confectionery chemistry, confectionery science to kids. So to show them that there is really science behind. And we are going to achieve this through our early stage researchers and technical staff. So here you see just the currently ones, but the number probably will increase as we proceed. So we have ESRs from different countries, from our different partners, and we also have our experienced researchers who will be guiding the ESRs, and also we will be learning throughout the project with the findings that the ESRs will get, we will get through all these collaborative activities. Well, we already have many communication tools. We will be posting all videos of this training school to our YouTube channel. It will be open soon, but we have already our other social media tools. We are on Instagram, we are on Twitter, we are on LinkedIn. If you are not following us yet, please follow us. And we have our web page is progressing. Our email address is SuChAQual@metu.edu.tr. You can always contact us over there. And we will also be sharing our videos and all files through Google Drive, and will give you the necessary links. And we have administrative personnel who are also ESRs in our project. So here you see them. There's 3 of them are already going to be ESRs as well, for management of secondments, for social media, and for our webpage. Okay, tomorrow is going to be a more intense day for you, because you will learn mostly NMR. I mean, of course, it's not expected that you will learn all NMR stuff in one day, but just to increase your awareness on the techniques. So we have 3 sessions, 3 lectures tomorrow. One is going to be from Resonance Systems. Dr. Leonid Grunin will talk about basics of NMR and time domain NMR. And then Professor Danuta Crook will talk about fast fill cycling NMR relaxometry. And then we will have Dr. Morris talking about magnetic resonance imaging with a more focus on mobile NMR sensors. And that discussion sessions are usually closing sessions, so do not think that as an extra session, because it will already be late night. So we will just be closing that day. And the 3rd day is going to be our NIR and IRMS day. So we will first start the day with SGI Isotech. Ivan Smadlovich will talk about food authenticity and adulteration by our IRMS. We'll be giving very nice examples on what they have done already by using these techniques and the advantages of these techniques, so of these super powerful technique. And then Mikhail Kodasevich will have his basics of NIR spectroscopy lecture. So you will learn even the history of the spectroscopy and this basic concepts, a very nice lecture. And then Dr. Rosario Castillo from University of Concepcion will talk about shortly chemometric fundamentals and applications.
Okay, good evening, everyone. I'm focusing more on as Dr. has mentioned in his talk, that we are focusing more on the functional confectionery. So this time, what we are trying to do is we are trying to use algae. Why we are trying to use algae? Because it's easy to grow algae. We can grow the algae at room temperature into the labs, instead of extracting the sugars from crops, for example, sugar cane, or from herbs as well. So in our case, we decided to go for algal biomass, and from algal biomass, there are a variety of sugars that we can extract, and we can use them in confectioneries. So the overview of my presentation is basically we are focusing more on algae first. That we discuss a few aspects of algae, and then we'll talk about sugars and sweeteners. We'll talk about those sugars and sweeteners as well that can be used as artificial sweeteners. And then the most important thing in my case, in my group as well, that what is the significance of algae in terms of industry? For example, if we are talking about the food industry or confectionery industries, are there some developments in terms of algae? Then we'll discuss about the application of algae in terms of nutraceuticals and pharmaceuticals as well. Why we are using nanosugars? Nanosugars, as the name suggests, that nano is we need these sugars in a very small amount, very small quantity, in nanograms. So a very little quantity of these sugars would affect is as much as that of the normal sugars as well. So the thing is, this kind of nano sugar, there is a possibility that these nano sugars would not be toxic, would not affect those effects that to the health that can caused by other sugars that are synthesized artificially. Then we'll discuss about the methodology that we are going to adopt in terms of the development of nano sugars from as a biomass. So as you know that algae is basically phototrophic. It goes in the presence of sunlight, and then it uses the light and sun energy, sunlight light energy, and converts it into the chemical energy. You can find algae in ponds everywhere in Pakistan. We can find algae in fresh waters and marine water as well. And these are microscopic. These are single cell. Sometimes these are single cell. Sometimes these are multicellular as well. They can go as a large seaweed as well. There are 4 types of algae. These are unicellular. These can go as colonia. These can go as filamentous, and these can go as multicellular as well. The basic concept of using algae biomass is that this is a tiny little industry, and from this industry, you can extract various compounds, chemical compounds. You can extract various biogenic materials as well, and you can extract sugars and proteins and many other products that are having application in biotechnology, pharmaceuticals, and nutraceuticals, and food industry as well. So far, we have isolated 4 algal strains, Diclosporidium DHM1. There is another Diclosporidium strain that we have already isolated from the fresh water, and we have characterized it as well in our lab. And then there is another Diclosporidium SYM. Why we are having 3 different strains of algae? You know that if you compare the genome, if we are comparing the genomes of these algal strains, these genomes might be variable in terms of their genomic and functional genomics, and their comparative genomics and functional genomics, and in terms of their physiologic characteristics as well, although they are from the same species. Then we have another strain which is Pectinodesmus DHM3. We have used this strain for different applications as well. So there's a brief introduction of the work that we have done so far. It's a very brief discussion, introduction of our work that we have done so far in our lab. We have synthesized different metallic nanoparticles like silver nanoparticles. These are nanoparticles that we are using them as antibacterial, anti-cancer, and we have used them on different cell lines as well. And we have used these nanoparticles to treat viral infections as well. At the same time, we have used nanoparticles as preservatives to enhance the shelf life of fruits and vegetables along with calcium alginate. To enhance the shelf life of fruits and vegetables by avoiding the bacterial infection and the fungal infection. We have worked on this aspect, and this paper was published in Material Science and Engineering C. Then we also have developed carbon nanodots using algal extracts, and using these carbon nanodots are being used as antioxidants, having some antioxidant properties. We also have developed the zinc oxide nanoparticles, and these nanoparticles, they have incorporated into the sodium alginate alginate films, and then these films are using as food preservatives to avoid bacterial infection and fungal infection. And we have submitted a patent of this product in Pakistan. So this is a brief introduction of our algal materials that we are synthesizing using different algal strains. As far as sugar and sweeteners are concerned, plants store energy, and this energy is converted by photosynthesis. This energy is converted into the chemical energy, and in the form of different compounds. And these compounds are made up of carbon, oxygen, and hydrogen. And then sugars are existing as monosaccharides, disaccharides, and oligosaccharides and polysaccharides as well. The most commonly sugar that is existing in that is extracted from sugarcane, sugar beet as well. This is the sucrose. And same is in algae as well. Sucrose is found abundantly in algae. So these are the sugars from algae. Sugars are carbohydrates. These are monosaccharides. These are oligosaccharides. These are polysaccharides as well. So we can find D-glucose, D-fructose, and D-galactose from algae. Monosaccharides such as glucose, fructose, and galactose are water soluble, and they are water soluble crystals. They form the crystals as well. Algae use glucose as a principal energy source as well. Okay, though it's important that algae grow in the presence of sunlight and it converts light energy into the chemical energy, but at the same time, if you provide glucose as a carbon source to the algae, it grows efficiently, and we can increase the biomass by using the glucose as a carbon source. And this biomass, when we enhance the biomass, we can use this biomass for different industrial applications as well. So energy is stored as various other sugar compounds as well. Then there are different other types of sugars like arabinoids are also existing in algae, fucose, glucosamine, galactosamine, glucuronic acid, and galacturonic acid. These are the structure of these sugars as well that I have mentioned that have been indicated on this slide. And these sugars are commonly occurring into the algal cells. They synthesize these kind of sugars. And again, algae synthesizing mannose, inositol, ribose, sugars as well. Rhamnose sugars, xylose sugars, and sucrose, as I mentioned earlier. This sugar is present abundantly into algal cells. Then sugars from algae, glucose monomers by alpha linkages from molecules such as amylose and amylopectin, they are occurring into algal strains. Then there is another algal species, Cryptophyceae. These species store starch outside the chloroplast and endoplasmic reticulum as well. Then there is another species, Dinophyceae, store starch outside chloroplast upon 5 nights. Rhodophyceae store starch as well, starch and grains outside chloroplast. Glucose monomers by beta linkage from cellulose as well. These are commonly occurring into the algal species. Not all, but various algal species, these also contain cellulose. And you know that cellulose, as far as cellulose is concerned, this cellulose can be applied to stabilize sugars. We will also apply these cellulose to stabilize the nano sugars when we manufacture them through algal biomass. Then freshwater algae store rhamnose in cell walls. There's a huge list of algal species that manufacture different types of sugars, like chromophyte and euglenoophyceae. They store polysaccharides outside the chloroplast. Then marine algae store sulfated polysaccharides in cell wall as well. Marine seaweeds, they also contain sulfated polysaccharides such as alginates and fucose in complex with cellulose and hemicellulose in their cell walls. So you can see these sugars, they are occurring into the cell wall, they are occurring into the endoplasmic reticulum, they are occurring into the chloroplast as well. These are present into the different organelles of these algal cells. Then some rhodophyte or red algae contain native agar. They also have sulfated polyanions and carrageenan cell. These are present into the cell walls. Carrageenan is composed of D and L galactose. It's a polymer actually. Then again another slide which will cover the sugars that can be manufactured, that can be synthesized from algae. Structured polysaccharides in algal cell wall contain turgor. Algal also demonstrate repressed photosynthesis due to oxygenous glucose. Then metabolic processes in algae are unique. There are multiple metabolic processes are going on into the cells, and they also produce monomers and polysaccharides and various other carbon hydrogen compounds. Then light harvesting carbon acquisition and respect of nitrogen sulfur assimilation is also a particular aspect of algae. Then they also have formed some secondary metabolites These secondary metabolites, in besides sugars, they also have application in nutraceuticals as well. You can, yeah, even the the biomass can be used as supplement sometimes, in terms of the food additives, or in terms of different energy products that can be used as a nutraceuticals. Then, as I mentioned earlier, we can synthesize sugar from algae. Sugars from algae converted to biofuels. It's a very important, because most of the times when we are talking about algae, there's a common concept that we are focusing on the biofuels, like lipids are converting into the biofuels. There are four types of biofuels at the moment: first generation, second generation, third generation, fourth generation biofuels. Now, in this case, even the sugars can be converted into biofuels. Microalgae go in fresh water or salt water, even the wastewater. You know that algae can be used to in bioremediation as well. So there are multiple applications of algae. But the point is, as far as sweeteners and sugars are concerned, very few studies are available that can have that can provide you the true picture that algae can be used to produce sugars, and these sugars can be used as um, sweeteners as well. Various companies such as Argenol, Sapphire Energy, Terra, Via, and Synthetic Genomes are working on projects for biofuel production from biomass. This is another aspect of algae. Now, as far as alternative sugars are concerned, sugars can be in the form of honey, maltose, palm sugar from maple syrup, and coconut sugars as well. If we honey and maltose, you can differentiate between these two sweeteners as well. Honey was world's primary sweetener and commercially used as honey can be available from different markets and as well, and using as a sweetener as well. Maltose sugar has some caloric content, and this is maltose is also acting as a sweetener, and is produced by some chemical reactions as well through hydrolysis of starches, and then starch is hydrolyzed to maltose in brewing beer. Then, if you're talking about the commercial application of maltose, is packaged as high maltose syrup and our replacement of glucose syrup, and it is in production of baked goods and confectionaries as well. So, then there are some other sweeteners as well: date and coconut sugar, maple syrup as well. Date palm sap is used to produce all sugar. Then coconut palm is also used to produce sweetener as well. Date palm sugar is packed as syrup, and then coconut sugar is consumed as alternative table sugar as well. Maple syrup, you can see that this syrup can be obtained from sap of different maple trees, and this maple syrup is being used as a confectionery as well. Maple syrup is also produced and used in butter, candies, toffees, and granular sugars as well. So, what are the sweeteners? As Massive has also mentioned, the sweeteners, these are products that can be used as confectionaries, and these can be used in baking industry as well. These sweeteners are ingredients to sweeten and enhance the flavor of foods. Then these sweeteners are many times sweeter than table sugars. These may have some side effects on human health as well, because if we are producing these sweeteners artificially, so these sweeteners may have some adverse effect in terms of obesity, in terms of diabetic situation of patients as well. However, if we are extracting these sweeteners from the natural source, like from plants, from microbes, from algae, from different other sources, for example, nicene as well. So, recombinant DNA technology, we can produce these sweeteners, and these might have some very good effect on the health as well. They are not cytotoxic for humans. And then small amounts are needed to achieve the same level of sweetness as sugar, because in these sweeteners, as I mentioned earlier, that very little quantity of these sweeteners, they can be very effective compared to the normal sugars. There are few artificial sweeteners as approved by FDA. We will talk about these sweeteners as well, like SSL-FAM potassium K. This is 200 times sweetener than table sugar. It has been used in soft drinks. It has been used in proteins and shakes. It has been used in drink mixes, frozen desserts, and baked food, and good candy and gums and table top sweeteners as well. So, but in this case, what happens that this type of a sweetener, it can also affect the gut microbiota. And if it affects the microbiota, there it can induce the glucose intolerance. It can enhance the glucose intolerance, which causes the weight gain in normal healthy individuals as well. SL-FAM is sold under the brand names Sun Sweet. There's another artificial sweetener. Adventam is a flavor enhancer manufactured by Ajinomoto as a food additive. It is 20,000 times more sweetener than table sugar, and it is heat stable and used for cooking and baking as well. Adventam is reported as a safe artificial or non-nutritive sweetener. So there are side effects as well of this sweetener. Aspartame, 200 times more sweetened than table sugar, and packaged as tabletop packets, prepared foods such as dairy products, nutrition bars, confectionaries, and beverages. It is made of aspartic acid and phenylalanine combined from aspartame as well. This is FDA approved, and daily intake of 15 milligram per kilogram of body weight. There is an adverse effect that if we use aspartame in large quantity can enhance the obesity. Aspartame is packaged and sold as a brand name NutraSweet, equal and essential every day. Then Nutam is a dipeptide compound made up of aspartic acid and phenylalanine. And again, amino acids are involved. They are making up these artificial sweetener, 7,000, 13,000 times more sweetener than table sugar, and it is used for baking, cooking as table sweetener. These are all the artificial sweeteners, and you know, if these sweeteners are artificial, they might have some adverse effect on the gut microbiota, and they can also affect some adverse effects on the metabolic profile of humans. Then fecal metabolite profile change with high lipid concentration as well. Nutam is sold under the brand name Nutam. Saccharin, 0-calorie sweetener, 300 to 400 times sweeter than table sugar. It's consumed in baked goods, drinks, chewing gums, and tin foods as well. FDA approved. It is FDA approved, and amount of consumption is about 5 milligram per kilogram of body weight. It can enhance the body weight as well. So the brand name is second brand name is Sweet and Low Essential Everyday Sweet and Low and Equal. Then sucralose. Sucralose is 600 times sweetener than table sugar, and it is packed as table sweetener and found in packed baked goods, beverages. And it is also FDA approved and acceptable. Acceptable daily intake is 5 grams per kilogram. You can take 5 grams per kilogram body weight. Can also affect on the body weight as well. Sucralose is sold under the brand name Panda and Equal. So these are all the artificial artificial sweeteners. You know how these sweeteners and how would you feel that they are sweeteners, and what is the molecular mechanism behind it? I don't want to go into the details, but there are receptors on your tongue, and these receptors are activated when there's a sweetener on your tongue, and then there's a release of triphosphate, and then there's a taste transduction channels that activate TRPMs. These are the molecular mechanisms involved, and this would lead to increase the cellular calcium and neurotransmitter release, and then you will feel there's a very soft feeling that you will feel the good taste. And basically these sweeteners, they are activating the receptors, the tongue receptors, and then they release certain molecules that signaling molecules that you would realize the player, and that you would feel that there is something very interesting going on. So as far as our studies concerned, we were talking about the artificial sweeteners, we were talking about those sweeteners that can be extracted from different sources, from plant source, from other microbial sources as well. But why we are focusing more on algal sugars? Basically the thing is there are few more advantages while we are using the algal biomass. Nowadays, we can see that the algal farming is getting very popular all over the world. We are growing algae into the labs, and it's very easy to grow algae. It's very easy to enhance the algal biomass, and after you can grow algae into the synthetic media as well, and you can isolate the algal strains from your environment, from the ponds and from the marine environment as well. And if you get the sugar profiling of these algal strains, you'll find many sugars as we have discussed in our previous slides as well. So there's a need to develop algal sugars at this stage. I have gone through few of the literature. There are though there is a huge amount of sugar produced and different types of varieties of sugar produced with the algal cells, but still no product is patented. Sugar product is patented from algae. Yes, there are few algal strains that can be used as a soft drink, for example. I can't remember the name of that algal species, but this algal species, when you are using drinking this algal species, it would feel like that you are drinking the strawberry shake. And there are alternative sweeteners. The thing is, if we are talking about the artificial sweeteners, they might have, as I've mentioned, they might have adverse effects in terms of patients' health, specifically when the patients are suffering from type 2 diabetes. And then there's a weight loss when there's a significant increase in weight if we are using those artificial sweeteners. So sometimes this weight loss is weight gain is prominent in adults, but it's not very prominent in kids as well. But sometimes we find some obesity in kids as well. So there's a need to find those alternatives that are natural source. So nano sugars, why nano sugars? Many times sweetener than ordinary sugars, and they when we are using them to a very small quantity, they reduce the calorie intake as well. And there are few products available in market in terms of nano sugars. Malaysian nano sugar, they have made these nano sugars from sugarcane. Hijra nano sugars, they also have made this nano sugar from herbs. I can't remember the name of these herbs, but this is also available in Malaysia. I think it's a Malaysian product as well. So these two types of nano sugar we have managed to find the literature of these two nano sugars, and it's still no literature available on the nano sugar that can be extracted from sugar beet or from other crop, and also from the algae or from other microbial strains such as cyanobacteria as well, or fungal strains as well. So these nano sugars are 5 times sweeter than other sweeteners. They have, as far as Malaysian nano sugar is concerned, 100% black sugar cane extract is there. No preservative were included into these nano sugars. No synthetic material was added. And then 80% lower calories is there than regular white sugar. So this is again a brief introduction of Malaysian nano sugar, sweetener drops extracted from sugar cane. The process dislodges negative carbon from sugar cane component, 600 times sweetener compared with sucrose. And there are few other commercially available sweeteners like Indian nano sugars, Biofuels sweeteners. There's a liquid sugar substitute available in a 1-drop solution. These are having 0 calories. These are having 600 times, 700 times more sweetener. These nano sweeteners contain sucralose as well. So why algae? As I've mentioned, I'm mentioning again and again, this is abundant, this is a fresh water, this is available in fresh water, this is available in stagnant salt water as well. and algae are consumed as food in several forms as well. Even algae is used as an animal food and fish food as well. Algae grow faster than food crops, as mentioned, and essentially required because it grows. It's a photosynthetic microorganism, so it grows in the presence of sunlight and produces biomass, and from this biomass you can extract sugars. And algae is composed of 6% sugars. This is environmental friendly. You don't need much space. Algae are the most efficient producers reported. They produce at exponential rate with minimum nutrient requirement. Algae are used for bioremediation, as I've mentioned. They have been used for biofuel production as well. Algae has therapeutic properties reported since ancient times. There are many compounds that have been extracted from algae that can act as antioxidants as well to cure cancer. Algae is a dietary essential in various cultures and requirements for various cuisines such as sushi or, for example, Japanese food. And it has zero toxic potential in comparison to the various artificial sweeteners introduced such as cyclamate, etc. So this is one of the major reasons why we are using algae is the products that are extracted from algae. These are not toxic for the cell. Algal biomass, micro algae, spirulina, and chlorella biomass is marketed as supplement. You can use them as supplement. These are processed products as well. The major processed products are agar, alginates, carrageenans, which are consumed by health and confectionery industries, and these prove to be very effective against gelling agents as well. Effective as gelling agents as well. Algal species are classified on the basis of diverse pigment combination as well. You know that these algal species, they produce the pigments, and these pigments, when they characterize these pigments are also having some nutraceuticals and pharmaceutical applications as well. These pigments, they are D-carotene, astaxanthin, and phycobiliprotein are the most popular commercial pigments. There is a possibility that these pigments may also have some application as a sweetener, and they may have some application in confectioneries as well. But we need to characterize these pigments as well. These pigments are consumed as colorants. They enhance the color of food as well. They can be used as additives, and they can be used as a nutraceuticals. So the algae and food industry, algal farming is very common in most part of the world. India, our neighboring country, they are investing a lot of money on algal farming, and they have established many companies and there are many other companies that are present all around the world, like Alga Prime, like Alga4, like Algavaya. They are using whole algae ingredients. The Algatech is also using these ingredients as well. And we are extracting oils from these algal, from various algal strains, and these stable oils providing excellent benefits for skin and hair as well. Then a high quality alternative to fish oil can be used as they're using in a company like Alga Prime. So the Alga Biotech food supplements, these are the company's name. Alga Biotech is they are providing the food supplement. Algama, they are also providing the food supplements. Micro algae food supplement are there. Nutraceuticals, they are providing health supplements, and these health supplements are manufactured through different algal strains. Similar algae health and dietary supplements they're providing. Ozone, biotech, health and personal care is there. They are using different strains of algae, and they are producing those products that are using as a supplement to cure human health. Algal pharmaceuticals, there are different companies like Glycomore. These are few of the names actually. We are talking about few of the names that are producing those products that are having application in pharmaceuticals. Glycomore. There are many other companies, hundreds of thousands of companies that are producing pharmaceutical products. The DIC LifeTech, they are using anti extracts, which can improve the memory and they can boost the health as well. They can be used as antidepressant. Astrareal, they are using their products are oil, water, dispersible powder, dried biomass, and supplements. So you can see the algae is having applications many industries, pharmaceutical, nutraceuticals, and food industry. Algal and sugar industry, for example, Porotiro is entering algae cyanobacteria to enhance sugar production for higher biofuel yield. In the past, they're using algae to produce biofuels, but they are enhancing the production of sugars. The specific cyanobacteria is basically bacteria, but it's photosynthetic bacteria that it's also using sunlight and produces sucrose and exposed to saline environment. And as a defense mechanism, it produces the sugar alcohol. The gene triggering this response was engineered to stay active and continuously secrete sugars. So they were secreting sugars. They're secreting sugars, extracellular sugars, and these sugars are excreting into the media in which these microorganisms are growing. So you can extract these sugars through water extraction from the culture separator. Again, confectioneries, for example, additive carrageenan additive is used, alginate packagings are used, agar diet food is used, guava cholesterol reducer is used, and they have used these different algal strains like Chlorella vulgaris, like spirulina, cyanobacteria, like sorbitol xylitol is used in gums production. They are producing these sorbitol xylitol by using the algal biomass. So what our methodology would be to produce the nano sugar from algae. We already have 4 algal strains in our lab, and my lab's name is Nanobiotech Lab at NUS. So we'll extract the sugars. Before extracting the sugars, we must have the sugar profiling of different sugars that are present into the algal cells. Then there is a production of nano sugars using nanocellulose and sugars from algae. And nanocellulose, why we are using nanocellulose? Because this nanocellulose would enhance the stability of the sugars. And then these sugars would be more stable when we are using them in confectioneries. Then there is a structural profiling of nano sugars and tests on cell lines and mouse model. We need to see that how much these sugars are environmental friendly, how much these sugars are not toxic to the cells and to the mouse models as well. Then there are series of experiments on cell lines, different types of cell lines, and then there are a series of experiments on the mouse model that will provide us the evidence that these nanosugars can be applied commercially in nano confectioneries as well. Firstly, we'll grow the algal culture, and we'll extract the biomass. We'll prepare the biomass. Then we'll go through the sugar profiling, characterization of the sugars. How would we go through the characterization of the sugars? We'll use different analytical techniques like HPLC, GC, GCMS, and then the structural analysis of the sugar is there as well. We will use XRD, FTIR, NMR, and then there will be development of the nano sugars, and these nano sugars then will be applied onto the cell lines and onto the mouse models to check their toxicity or to check their suitability for the human health. So this is the platform that we are using at the moment in our lab. This is the algal. We are growing algae. We have the platform in our lab. We are growing algae into not a very big fermenter, but these are basically we have tube lights in the rack, and these tube lights are providing light to these microorganisms, and then we're growing these microorganisms into the lab conditions. And then we harvest algae after 30 to 40 days. And after the filtration of the biomass, we centrifuge them at 2000 RPM for 10 minutes and remove excess liquids, stuff like that. We dry the biomass. And then after drying this biomass, grind them. And in the form of a powder, we prepare the extracts, and these extracts, through the SOX extraction, we prepare the extracts. And through these extracts, there is a possibility that we extract the sugars from these extracts. We will extract the cellulose from these extracts, and then we will convert these sugars or cellulose into the nano sugar. Sugar profiling, there are different types. There are different types of methods involved. Once this sugar profiling is through HPLC, this sugar profiling through DCMS, and then we'll use XRD. We'll use sometimes what happens that these extracts have to be analyzed through FTIR. Why we are using FTIR? Because we need to understand what type of functional groups are there, what kind of type of compounds are there into the algal extract. And if we have the nano sugar, if we extract the nano sugar from the algae, there are chances that we'll extract the nano sugars, and then we'll do the NMR to find the structure of these nano sugars, and then some analysis as well. Sugars, they are separating charges on sugars. Monosaccharides and disaccharides are separated by ion exchange, column chromatography. You can use TLC as well to separate the molecules. Water extraction is there to extract the sugars, and through GC and HPLC, you can identify the sugars. There's a huge data bank that we can compare our results with the with those that are available into the database, and comparing our results with that database, we will find that these type of sugars are present into our Algal strains. And chromatographic techniques differentiate sugars on the basis of partition coefficients, polarities of size, and stuff like that. And then based upon the separation, we can separate the molecules, and then after separation of molecules, we can convert them into the nano sugars. Then quantify the sugar is very much important. How much sugar is there? This is again a profiling of the sugars into the algal biomass. Sugar can act as a reducing agent and yield precipitates. And there are enzymes into the biomass as well that convert these sugars, large molecules, into smaller molecules. Then these sugars would be acting as a nano sugars. And we have to quantify these carbohydrates. We have to determine the exact quantities in samples as well. The carbohydrates will also determine through the spectrophotometric analysis as well, through the gravimetric analysis by titration. These are the methods that we will apply to determine the carbohydrates into the algal extract. Why we perform the titration analysis at the extract will require the copper sulfate with methyl blue, and then extract quantity required to change color. If there's a change in color, this change in color will tell us that how much sugar or carbohydrate is there, so that we can extract for our purposes. Then the gravimetric analysis will also provide us the evidence that sugars are there, and we can extract these sugars from the extract. Then analytical methods of mining sugars, high pressure liquid chromatography, then gas chromatography is there, chromatic methods will be used. Then instrumental techniques such as hydrometer, refractometers, and electronic tongue are used to determine the chemical composition of sample and sugar profile into the algal extract. Sensory evaluation is very much important as well. There is a traditional use to determine the taste of fruit and vegetables, and we at the end we use bricks of fruits and vegetables that are commonly used to and measured by gravimetric methods using the hydrometer, and these hydrometers by a specific gravity and calibrates it with sugar concentration. So you'll find the sugar concentration into the algal biomass by using these techniques. Then a refractometer, then HPLC. HPLC is one of the methods that we can compare the sugars, that how much sugar that are existing into our biomass, and then how much sugar is there that can be used to produce the nano sugars and or the functional sugars as well. These sugar profiles, for example, food and vegetables, can be determined using this NIR, visible NIRs technique, and by utilizing visible and near infrared NIR region of the spectrum as well. So algal nanosugars, nanoparticles have the shape of fibrils and are water insoluble. These nanoparticles are very small, they are nano in size, very minute little tiny particles, and they are more effective compared to the big molecules. For example, sugars they attach to the hydroxyl of C6 carbon chains. Sugars will attach with these cellulose block. Solubility of the sugars in solution would be dissociate from cellulose. Means what happens that these cellulose will bind with the sugars, and then when these nanocellulose will bind with the sugar, they will provide more stability to the sugars. And once we are using these sugars, these cellulose will be dissociated from the sugars, and these sugars will be dissolved to the liquid. Then dissociation of sugar from nanocellulose solution increases solubility of sugars. This solubility will be increased, and then due to fibril shape of the nanosellulose will be there, and it will provide the stability to the sugars if it binds with the sugars. Then algal nanosugars, acid hydrolysis of cellulose, means this method involved there. these details are too much technical details are there that we use to produce the nano sugars from algae. And, there's no need to go into these details. We are just providing some introduction what type of method we use while we synthesize, we will manufacture these nano sugar from algae. Sugar solution, for example, is dissolved in nanocellulose, for example, at 40 degrees centigrade, that would be stable, and then sugars from algal extract will be concentrated with nanocellulose, and then 70% glucose, fructose, xylitol, arabinose, fucose, and laminaria, 30% nanocellulose would be there. For example, if nanocellulose is binding with 70% glucose, and nanocellulose is binding fructose, if nanocellulose is binding with sucrose or xylitol, these are different types of sugar. So these nanocellulose will provide stability to these nanosugars. So this profiling, again, when we make up these nanosugars, these nanosugars, firstly we were profiling the sugars into the algal strains using different analytical techniques. But now, once we have manufactured these nanosugars, we use different types of techniques like XRD to characterize these nanosugars. XRD, FTIR, this FTIR will tell us how much functional groups are there that they have acquired from algal biomass. Then through NMR spectra, we will try to solve the structure of these nanosugars. Then SAM and PEM would be there to find the size of these nanosugars. So at the end, as I've mentioned, we need to give a try to we need to find out that how much these nanosugars, how much safe are these nanosugars if we are comparing these nanosugars with artificial sugars. So are these safe on the cell lines, normal cell lines, and even there we can use different types of cancer cell lines as well onto the normal cell line. We find out if there's any adverse effect of these nanosugars on these cell lines. So sometimes what happens, we need to optimize the concentration as well, how much concentration would be there that might be toxic for the cell. And then we'll characterize these nanosugars onto the mouse model as well. So, so this is basically a brief introduction of what we are going to do in this project. And then I also have mentioned that why we are using algae. So it's a tiny little industry, and we are trying to exploit this little industry into the confectionery industry as well. Thank you. If there are questions.
Thank you, Professor.
Yeah.
So can we ask some questions?
Yeah, of course.
I'm trying to visualize in my mind this nano sugars. So you have basically the nanocellulose,
yeah,
and sugars extracted from the algae will be absorbed onto these crystals.
Yeah, there are two types of strategies. One is that we'll use the nanosugar cellulose to stable these nanosugars, and there's another strategy in which we'll further converting these bigger molecules of sugars into the nanomolecules as well. And then one type of the nanosugars, we will have the cellulose bind with the sugars, and another type of the nanosugars in which we will not bind the cellulose with these nanosugars. These are the individual sugars.
Okay, so which strategy normally do you think will work much better?
I think the cellulose one, it will provide some stability to the sugars. So yes, we'll try. There are few literature. There are few papers available as well in which they have used the cellulose as well. But in my case, what I'm trying to do is that there is no need of cellulose, and what we are trying to do is that we are extracting the sugars, and we are trying to convert these sugars into the nanosugars. There are enzymes actually. These enzymes will also be provided into the algal strains.
Okay, so
that will reduce the sugar molecules into the nanosugars.
So this is, I mean, the molecular size will decrease. That is what it will make the nano. Then, if we don't have the cellulose.
The cellulose is again that would be again at a nano scale level. Okay. Cellulose would be again a nanoscale level. It's a small little fraction of the cellulose. Okay. Yes, but in case of sugar as well, we are, yes, the sugars would be converted into the nano sugar. So the cellulose and the sugars would be at the nanoscale.
Okay. Okay. And then in the trials, you said that we will test the efficiency. What did you mean by efficiency? Efficiency of what?
You know what happens that we are making different products from algae, and what we have observed so far from algae is that the products that we have extracted from algae, these are not cytotoxic. Okay. Why they are not cytotoxic? Because they are acquiring those functional groups that are present into algae, and these functional groups, they minimize the toxicity of the compounds in terms of their effect to the cells. Cells, you know, cell lines, if you're working on the cell lines, we'll find out that how much these compounds or sugars would be toxic to the cell lines. And then we'll move to the mouse models. Why we are moving towards a mouse model? Because we are trying to find out that how much concentration of the nano sugar would be there that might affect the weight of the mouse model, that might affect the organs of the mouse model.
Okay.
Are you getting my point? Yes.
Thank you very much.
These experiments are very much important to run, because if we are saying that we commercialize these products, so before commercializing these products, we need to find out the perfect nano sugars in terms of the healthy, in terms of the healthy mouse models, and again, what kind of side effects. We are not talking about those side effects that they'll affect the organs. We are talking about those side effects that if, for example, if we are using the concentration in nanogram, this nanogram concentration, is there any effect on the obesity, for example, or not? Yes.
Thank you. I mean, it will be really very relevant to our project. That is very exciting.
That's what I'm trying to tell you, that there's no patent. There's no patent as far as the sugars are concerned from algae at the moment. I've gone through one patent there. I think that patent was published from I think US or China. I can't remember. But there's one patent from algae. There's a huge potential in algae. We can you can see the dozens of sugars that can be extracted from algae. And these, if we are talking about the sugars only, if we don't convert them into even nano sugars, we use these sugars into the natural concentration, that might be very effective in confectioneries as well. Okay, let's forget the nano sugars, for example. We are just talking about the sugars, ribinose, for example, sucrose, for example. Have you heard any paper that they have extracted sucrose from algae? Yes. So, but there's a huge potential with this microorganism that we can perform these kind of experiments on this. But there are different types of strains. As I was mentioning, that there is one strain that I have also written this point when we were submitting the grant application. When you were submitting the grant application, and I was putting my part into that grant application. There is one strain of algae that we can even drink, like a strawberry juice.
Wow.
So there's too much potential into this microorganism.
So we have 4 years to explore it in much.
Yeah. Okay. If we find out one very good nano sugar from, I have 5 strains, for example. Okay, if one strain will provide us a very good nano sugar of commercial application, yes, it's fine.
Yes.
Okay, we can have even 4 different strains, 4 different types of sugars, 4 different types of profiling, sugar profiling. It's again a beauty of the microorganism. If you compare the genomes, if we are talking about the same species of, like Dictyostelium, there are 3 different strains of Dictyostelium, and if we analyze the genomes of these Dictyostelium strains, there's a difference. Phenotypic characteristics are different. Physiological characteristics are different. Sometimes what happens, that one strain will provide you enough sucrose, but the same strain, the different strain from the same species will give you very good, huge amount of fructose.
Okay.
So it's all about genomics, comparative genomics, and functional genomics.
Okay. Thank you, professors. Thank you.
Thank you.
Okay. Any other questions? I mean, it is an area where it has really great potential. So I think we might have more questions to ask Professor Singh.
Can I ask some questions, Majid?
Yeah, of course.
Okay, great. At first, I want to thank Dr. Hussnain about his very informative presentation, and I have some small question. You mentioned that you produce in your laboratory 4 or 5 types of algae. It's right?
Yes.
Why you choose? How you choose this exactly types of algae? They have some advantages, or why exactly this algae? And maybe you can shortly say about the advantages.
Yes, it's a very good question actually. What you know that basically we isolate these algal strains from the environment. We collect them from the environment. There are ponds, there are water ponds, there are rivers, there are lakes, there are ocean, marine microorganisms as well. So what we do, we isolate the different strains, different algae from different locations. These 4 types of the algal strains, they are from different locations. 4 or 5 types of different algal strains, they are from different locations. Some of them are from the fresh water, some of them are from the stagnant water, some of them are from the marine water. So yes, when we characterize them, as I've mentioned, that even if for example, Dictyostelium is one species of the strain, but if there are 4 different strains of the same species and we analyze them for the sugar profiling, these 4 strains will give us the different results. Different types of sugars are there. So it's very interesting. You know, if we, for example, if we get some strain from Turkey, if we get some strain from Belarus, for example, if we get some strains from South Africa, I've spent some time in South Africa as well. And then we analyze these strains, Dictyostelium strains, they would be different. Their sugar profile would be different. Why is it so? It's because of the genomics and proteomics. Their genes and their proteins, they're expressing these sugars, molecules, metabolites, and as a result of this metabolic profile, there are different types of sugars are there. And yes, what we have done, we have taken the samples from different water sources and we have grown them into the lab. These cultures were not pure. We made them pure actually. There's a possibility. Yes, I know there were mixed cultures. There were mixed, for example, there were 2-3 different species into one sample that we have collected from, for example, pond from there's a place in Pakistan, Color Kahar. It's the name of that place. We have taken samples from that place and we managed to isolate 3 different species from one place. 3 entirely different species. And these 3 different species, they are giving you different results. Different types of compounds we are making, different types of biogenic materials we are making from them.
Okay, thank you. Any other questions to Professor Singh?
Hear me sit?
Yes, Rosario, sure.
Rosario, hello. Thanks, Hussnain, by your presentation, very interesting. And I have some question. I don't know if you have, or maybe another person in the session, in the project from the industry, for example, if you have some evidence of the use of the sugars obtained from algae or no?
There's, as I've mentioned earlier, there's only one patent that I've come across through that they've extracted sugars from algae. Yes.
Okay.
And then there are papers actually. There are few articles. If you go to this site, I'll link this slide to you. This one. There are papers over there. In that papers, they have seen different types of sugars that are expressing into the different parts of algae, cell wall, chloroplast, and you can see over here chloroplast, endoplasmic reticulum as well. So yes, they have done the profiling, but the thing is, they have done the profiling, but they have not extracted sugars, and then they don't have applied these sugars as nano confectionaries, for example.
Okay, and in these cases, I know that the chemical composition of algae varies in a fast way. For example, in different seasons, or if the algae comes from different places. And how can you assess the biomass stability to be used in, for example, the confectionery industry? I don't know.
Yes, we have to perform analytical analysis. For example, there are a few tests as well. Spectrophotometric analysis tests I have indicated to the tests as well, and these tests will give us the sugar profiling. And for example, if you go into the details of these sugar profiling tests, then we can use HPLC, we can use GC, gas chromatography as well. We can also use ATTA-UR. Yeah. And then at the end of the day, if we find some good sugars, then we go for NMR to find the structure of these sugars as well.
Okay, thanks.
Thank you so much.
Okay, I have another question in parallel with this. So, are you going to purify or isolate one type of sugars, or it is going to be like a mixture of different sugar monomers?
I think we have, if we have different types of sugars, what we can do, we can go for one type of sugar as well.
Okay.
Basically my aim and objectives are there to purify one typical type of sugar that is not cytotoxic, that is not harmful for the models that we have mentioned, mouse models, for example. So yes, fine. But sometimes what happens that if we have combination of different sugars, that might be very good as well sometimes. So we'll see both. Firstly, we'll go for individual sugars. So for example, we can work on sucrose, we can work on fructose, we can work on lactose, for example. And at the same time, what we can do, we can find that if there is a mixture of all these sugar in the form of a nano sugar, what could have this effect on our models, on our cell lines, for example.
Okay, so
we can compare the results.
Okay,
but my priority is to go for individual sugars.
And what about taste? One of our partners asked actually me, let's say that if you want to put in a confectionery product, the taste, the sweetness perception, how would it be so different, do you think?
No, it's the thing is, if you're talking about the nano sugars, very little quantity of nano sugar would have a very good effect. Like it would be like, as I've mentioned in this case, where we were talking about the Malaysian products, for example, they have taken these nano sugars from sugar cane, this one. And you can see over here, the calories are very less, and they are more effective, 5 times more sweetened than ordinary sucrose.
What makes them less digestible so they have lower calories?
Very little quantity we are using. At the same time, we are using the natural products. We are not using the artificial products. And these natural products, they are not cytotoxic. They are not toxic for the humans. If we are talking about, for example, the products that we are taking from plants, and if we are making these products from artificial process, there's a huge difference between these two products. Why? Because in artificial products, we are using those components, those chemical reactions that might have toxic effect. But if we are using the natural source, in our case, we have made many products. And even if we are synthesizing the silver is very toxic for the cell lines. But if we are making this silver from algae, the toxicity is compromised.
Okay.
Why is it so? Why is it so? Because they have acquired this nano sugars. They acquire some other functional groups from the algal extract, and these functional groups, they'll minimize the toxicity of these nano sugars. That's what we have received for. Because in our case, when we are synthesizing the metallic nanoparticles like gold or like silver, same effect is coming from the functional groups, that if the functional groups are acquired through the algae and these functional groups are having the synergistic effect with these silver nanoparticles, their cytotoxicity is decreased, but the function is increased as antioxidant and as
Okay.
antibacterial.
Thank you, Professor.